All right, so depth first search. Just wait. All right, so in depth first search, you start from the root node, okay, and then um, you started to explore the neighboring nodes in a deeper level. In case of breadth first search, what you did was you explore all the neighboring nodes, right? You write down all the neighboring nodes, and then after visiting all the neighboring nodes, you started exploring them one by one, right? Unlike breadth first search, depth first search is going to explore the adjacent nodes one by one. Okay, let me give an example. Before that, uh, one more important point about depth first search is that in depth first search, you use a stack data structure. Okay, so, in case of breadth first search, you are using queue. No, here you are going to use stack data structure. All right, so let me give one simple example of this depth first search. Depth first search is, the traversal is also similar to pre-order traversal, right? You have heard of pre-order traversal, right? So it's the same as that. Let me give one simple example. Um, for example, you have to traverse this graph two, three, and you have four here, and then five, six, and seven. Okay, this is three. Okay, so using DFS, if you are to traverse it, you will first explore this root node, okay, and after that you have two adjacent nodes, neighboring nodes 2 and 3, but you are going to explore only one first. So you're going to explore two, okay, you explore two, and then you're going to go to deeper level. Two has adjacent node 4 and 5, but you're going to look at only one node, 4. Okay, after 4, if you try to explore 4, okay, there are no other neighboring nodes, right? So you're going to backtrack, you're going to go back to the previous node. Okay, so that is 2, right? So, and you're going to explore this node again. Okay, 2 has one more adjacent node which is not visited, so that is what, 5. 5, after 5, if you're trying to explore it, you don't have any other nodes, adjacent nodes which are not visited, right? So you're going to go back to 2, right? 2. And then 2 has already explored all the or visited all the neighboring nodes. So you're going to go back to 1 and check for 1 if there are any adjacent nodes which are not yet visited. You have 3, right? So you write 3. And then you're going to explore for 3. You have 6 and 7, but you're going to um, explore only one, that is 6, right? 6, and then after 6 you don't have any other unvisited adjacent nodes, you're going back to 3, and then 3 has another unvisited node, right, which is adjacent to it, that is 7, right? 7, and after 7 there is no other nodes which are not visited. And if you look at the graph, you have only 1, 2, 4, 5, 3, 6, 7. So it's completed. So this is a DFS of this graph. All right. I hope my screen was visible. Okay. So let me just write it again. I have not used the implementation of stack here. I'll tell you how you can use stack here. See, this is a stack. This is where you write the visited nodes, right? I'm going to repeat it again from the beginning. First, you started this root node, that is 1. So you write 1 here in the stack. And then you explore 1. You explore 1 and you have adjacent nodes, okay, 2 and 3. But in that first search, you're going to explore only 1 first. So what should we explore? We will explore 2, right? So you will visit 2. So write 2. 2 is visited. And after that, 2, if you will explore 2, okay. If you explore 2, you have adjacent nodes of 2, 4 and 5, right? But according to that first search, you're going to traverse only one adjacent node at a time, right? So you will explore, I mean, for 2, when you explore, you are going to write only 4, right? So 4, you visit 4, then you write 2 here in the stack. Now look at 4 and try to explore 4. 4 has no adjacent nodes, so you have to go back to 2. So just pop this out, okay? Now, from this. I really don't know what is happening. This usually don't happen. Okay. I don't know. Just wait. All right, I hope it's fine. Okay, so I hope it's clear to everyone. I'll just do one more example on this. Then uh, just wait for some time. All right. So let me do example two. So let's say you have these nodes 1, 4, 3, 2, 5. The same graph that was done for the that was done in the second example of BFS. Okay. Now you're going to traverse it using BFS. 10, 9. All right. So how will you do this? If you are doing it using DFS, then here you're going to write all the visited nodes. Okay. And here you're going to keep a record. In this stack, you're going to keep a record of all the suspended nodes. Okay. So now let's start at the root node, that is 1. Okay. All right. So if you started 1 in DFS, you're going to you're going to explore only one node at a time, right? So you have so many adjacent nodes, 4 and 2, but you're going for 4 only first. 4. Okay. You have explored 4, so suspend 1 here. Now, after that, 4 has adjacent nodes 3, right? Okay, do it like this: 1, 4, and then 3, right? You're visiting 3 now. So suspend 4 and write 3 here in the visited node. Okay, these are the visited nodes. Now, after that, look at 3 and see how many adjacent nodes are there. You have 10, 9, and 2, but you're going for only one. So let's go on with 10. You have 10. Okay, you have 10, so suspend 3. Okay, now explore 10. If you explore 10, okay, there are no other unvisited adjacent nodes, right? So what will you do here? You're going to go back here to 3. So if you go back here, you'll pop this out and explore 3 again, and see if there are any unvisited adjacent nodes. You have 9 and 2. So let's explore 9. Okay. After 10, you'll explore 9. And um, you will not write 9 here, okay? Because you are exploring for 3 now. So 9 will come here, right? 9. So 9, after 3, you visited 10, and then you visited 9, right? So Okay, now you explore 9 again and see if there are any adjacent nodes. No adjacent nodes, so you go back to 3, right? 3, and then write 3 here in this stack. Okay, and explore the non adjacent the adjacent nodes which are not visited. You have 4 and 2. 4 is already visited, you go for 2. Okay, 3, 2. Now 2 will come here, right? Okay, and then you suspend 3 here, right? Now check for 2. So many adjacent nodes, right? 5, 7 and 8. Let's go for 8. Okay, we go for 8. Okay, we go for 8 and then you'll suspend 2 here. Now explore 8. You have 5 and 7 not visited adjacent nodes, right? So let's go for 7. Okay, 8. After 8 you have 7, and then 7, suspend 8 here. Okay, and explore for 7. You have unvisited adjacent nodes 5 only, right? So write 5 here, and for 5 you have unvisited adjacent node 6, right? So write 6 here. Okay, and now check for 5. Okay, what are the adjacent nodes of 5? You have 6, 2 and 7, right? Adjacent nodes of 5 are 6, 2 and 7. And look at your graph, your spanning tree. 5 is connected to 6, right? And also 7. But there is some connection of 5 with 8 as well. So do it with a dotted line like this. Okay, and 5 and 2 as well. So between 5 and 2, draw a dotted line like this. After that, you'll pop this out. Okay, you'll delete this from there and go for 7. 7, look at 7 in the graph. You have connection with 5, 8 and 2. 7 is connected to 8, 7 is connected to 5, and there is no connection between 2 and 7 here. So just make a dotted line like this. Okay, and after that pop this out. And again you have to explore for you have to look for 8 again. 8, you look at 8 and it's connected to 2, 5 and 7. Look at 8, is it connected to 2? Yes. Connected to 5? Yes. And 7? Yes. No need of doing that. Look at 2 again. 2 is connected to 1, 3, 5, 7 and 8. 2 connected to 1, so make a dotted line here between 1 and 2. Okay, 2, 2 is connected to 5. Yeah, can you just tell me where I have lost the connection? Maybe it's because I'm recording the video, that's why this problem is happening. I don't know. Yeah, do you want me to repeat this or go to the next? Let me just give a difference between BFS and DFS. In BFS, the first one, the previous one that you did, you explore all the adjacent nodes, right? And noted and visit all those adjacent nodes, right? And after visiting all the adjacent nodes, you explore them um, uh, one by one, right? And then explore all the other adjacent nodes. But in this case, you are going to explore the adjacent nodes one at a time and go to the deeper level. And only after completing one adjacent nodes, right, you are going to explore the other adjacent nodes in a deeper level. So that's the difference. I hope by looking at the graph itself, you can make it out. And I don't think so. I need to repeat it. If you want me to repeat it, then let me know in the chat box. If not, then I'll proceed to the next topic. Yes or no? Okay. So next topic we have depth limited search. Okay, so in this type of search, uh, you are going to be provided with some predetermined depth. Okay, so this type of search is also similar to uh, depth first search, which we just did previously. Okay, and there are two terminating conditions here. You have failure value and cutoff failure. Failure value is when there is no solution, and cutoff failure is um, when you terminate on reaching the predetermined depth. Okay, so let me just give one example of this. You have, I suppose you are given this node C, D, E, and F, and G, I, J, H. Okay, and this level is level 0, this level is level 1, and this level is level 2, and this is level 3. Okay, and J is the goal node. Okay, J is the goal node. You are given the goal node, and as I said, you are given a predetermined depth. So the predetermined depth is 2, which means, I'm sorry, okay, which means that you're going to explore to depth number 2, right? Okay, so how are you going to do this? According to the theory, it says you're going to traverse it similarly like depth first search now. So using depth first search, right? Okay. First you will explore X, okay? And then A, and then you go to C. And C is in level 2, right? And the predetermined depth was 2, so you will not go beyond this, okay? You'll not go beyond this, and you will trace back to this previous node A and see if there are any unexplored adjacent nodes. I mean, yeah, unvisited adjacent node. There is D, so you'll write D, and then you will go back to A, and A has all its adjacent nodes explored till the predetermined depth, right? So you'll go back to X and explore X and see if there are unvisited adjacent nodes. There is B, so you'll write B here, okay? And check for B, you have I. After I, you have H, but that is in level 3. Then the determined depth was 2, so you will not explore for this. You'll go back to B and explore for B again. And B has unvisited adjacent node J, right? Left. And J is the goal node. So you have reached the goal node, so that's it. So the final um, and depth limited search that you got is X, A, C, D, B, I, and J. Okay, so it's simple. Let's go back. Let's go to the next type of search: iterative deepening depth first search. Okay, so in iterative deepening depth first search, okay, uh, it's a combination of DFS and BFS, and these algorithms find out the best depth limit. And how it does is it does it by increasing the limit, okay, until you find the goal node. I'll give one example on this. Okay, so for example, uh, you have this question: S, A, D, B, F, and H, C, E, and G. Okay, so this is the graph that you're going to explore using iterative deepening depth first search, right? So how will you do that? First, you will make a table. You'll write depth here, and you'll write the traversed nodes here. Okay, as the theory says that this algorithm performs DFS up to a certain depth limit, and it keeps increasing the depth limit after its iteration until the goal node is found. Okay, so how will you do this? First, this is level 0, right? Level 0, level 1, and level 2. So first we go to level 0, and you have node S, right? And you are going to explore level by level. You are till here now. Next level would be this. Okay, you're going to explore till level on this level on. So depth 1 for this level depth, you have um S. After that you will visit A. Okay, and then no other nodes, right? If in level 1, adjacent nodes in level 1, so you will have C, SAC. Now you have explored till this level, okay, level 1. And okay, I forgot to tell you that G is the goal node. Okay, this is the goal node. So till here you have not reached the goal node, so you're going to increase the limit. Okay, see, it says in second point, this algorithm find out the best depth limit. It does it by gradually increasing the limit until a goal is found. So until you find the goal, you are going to increase the limit. You are going to increase the level. So till now, till at level 1, you don't find the goal node. So you're going to increment the level by 1. Okay, 1 plus 1 is 2. So and at level 2, you're going to explore till here. Now you have um, from the root node you have S. Okay, remember we are using DFS. Okay, we are using DFS traverser. So S, adjacent node A, you will explore A, then you will explore D, right? Adjacent node D, and then after D at level 2 you don't have any other adjacent nodes which is unvisited. So you are going back to A and explore A. A is having adjacent node B. After B there is no other, so you will go back to A. A has already explored all its adjacent nodes, so you go back to S and explore S and C, the neighboring nodes or the adjacent nodes of S which is not yet visited. You have C, and then C has unexplored, unvisited adjacent nodes E and G, but this is depth first search, so you will go only for one at a time. You write E, and after that E, at level 2 you don't have any other adjacent nodes of E, right? So you will go back to C and explore for C. You have G, and G is the goal node, so you stop here. Fine, G is found, the goal node is found, so you stop there. All right, so next, um, the last type of uninformed search is bidirectional search. Okay, it's in slide number 2. Okay, okay, so in bidirectional search, this type of search, and what are these two searches? These are forward search and backward search. For the forward search, it starts from the initial state, and for the backward search, it starts from the goal node, okay, the goal state. And these two are done simultaneously. Okay, so how is this done? Let me give an example again. For example, you have a graph like this, C, D, E, F, G. Okay, so now as it says that um, you are going to use forward search and backward search. So let us look for the this you have to make a table for the forward search and backward search. Okay, here this is for forward and this is for backward. Okay, I'm representing it by a letter F and B. Okay, so for the forward search, it says you start from the initial state. This is the initial state. So you go, and this bidirectional search is following breadth first search. Okay, it's following breadth first search. Okay, so now we start from A. In breadth first search, we write all the adjacent um, nodes, right? So next level you have A, B, and D, and you're going to explore for B, right? Sorry. You are going to explore for B, right? So B is having adjacent nodes D, right? So D is already visited. You don't have to do it for that. Okay, so I'm just wait a minute. This is not D, this is C. Okay. A, B, C, right? Adjacent nodes of A are B and C, A, B, and C. Then you explore B. When you explore B, you have D. Okay. And it says that the search stops where these two graphs intersect each other. So they intersect here now, and you are at this point D node. So you'll stop here. You'll stop the forward search here. Now, for the backward search, you're going to start from the goal state. So goal state G, okay, and then G has adjacent nodes G, E, and F. G, E, and F, right? So after that, you're going to explore for E, right? After G, you explore for E, and it is having adjacent node F. So G, E, F, D. And D is the intersection point of these two, uh, mm, you know, of this graph, I would say. So you'll stop here, and the final representation, you're going to do it this way. The forward search at the beginning, A, B, C, D, okay, and then backward search is D, F, E, G. So after D you have F, F, E, and G. So this is the path after using bidirectional search. Okay, and I'll give one more question. You can do this on your own, and tell me the result in the next class tomorrow. G is the goal state. Okay, so traverse this using bidirectional search. Okay, so this is the assignment. um any one of you have any problem with the previous lecture? Let me know. If not, then it's that's all for today. Yes, anyone? Anything that you want me to repeat?
No, ma'am, we will revise. If there is any doubt, we will ask.
Okay,
Ma'am, is
then you can
tomorrow
leave
a holiday?
tomorrow. Let me just check it.
Ma'am, tomorrow is Lodi, I guess.
Lottie, tomorrow is it a gazetted holiday?
Ma'am, we have not received academic calendar for holidays of 2026.
If you, yeah, if you get to know information before me, then you can let me know. Huh? If I get information before you, then I'll let you know. If I don't get any information, then I won't update. Yeah, anything else? Somebody said something. Okay. Good, then you can leave.